lesson is just a refresher of what you would have learnt in grade 8 if you were at MIS in grade 8. If not, don't worry, this podcast should teach you a little bit about right angle trig. So, we are starting with right angle trig. The first thing we need to know is our good old SOHCAHTOA. And this is then going to help us do everything that we need to do with right angle trig. So what you need to remember is that S is for sine, C is for cos, and T is for tan. Then the other thing that you need to know is what the other letters stand for. So if I just grab a right angle triangle here, and you should already remember that if we have a right angle triangle, we already know one special side, and that's the hypotenuse. And that's always the side that's opposite the right angle. Now if we have any angle, let's say we use this angle, we'll call it theta. Theta is just a Greek letter. You can use X or any letter you like. And the other two sides are named according to their relationship with the angle. So in this particular triangle here, this is opposite theta. Okay, opposite. And then the one next to the angle is called the adjacent side. So the first thing you need to do when you have a right angle triangle is identify which sides you know or that you're trying to find. And then that determines whether we use sine, cos, or tan. Because the O stands for opposite in our SOHCAHTOA, the H is for hypotenuse, the A is for adjacent, H is for hypotenuse again, and O is for opposite again, and A is for adjacent. So depending on which sides determines on whether we use sine, cos, or tan. So let's get started. Here we have a right angle triangle. Remember, SOHCAHTOA only works for right angle triangles. The first thing we do, figure out which sides we know. Here's our right angle. Opposite the right angle is 9.6. So we must have the hypotenuse. And then it's always in relation to the angle, whether you're trying to find an angle or whether you know an angle. So the 61 degrees is the angle we have, and opposite that is the side we're trying to find. So that's our opposite side. So now we know we have the hypotenuse and we want to find the opposite. So that's looking at then our first part of SOHCAHTOA. So we must be using sine. Now what you need to remember is that sine, cos, or tan are useless without an angle. You can't just write sine. If you press the sine button on your calculator, nothing happens. It's a ratio, that's all it is. That the sine of a particular angle is always the opposite side over the hypotenuse. So here, sine of the angle, so sine 61. And that is the ratio of the opposite side, which is x, over the hypotenuse, which in this case is 9.6. Then we just have to do some basic calculator work and equation solving. So we want to get rid of this 9.6, so we multiply both sides by 9.6. I like to write it in front of the sine or the trig ratio, otherwise you get a bit confused with the 61. So we have x equals 9.6 sine 61. And then it's just a matter of putting it into our calculator. So if I just pull my calculator up here. What's very important is when you're putting this into your calculator, when you're doing trigonometry, you need to make sure your calculator's in degrees. So if it's not, you'll be able to tell because you'll get some sort of funny answer that won't really make sense to your question. So let's see, let's hope that I'm in degrees. If you're not in degrees, you can just go to mode, and then you'll see here, the third one down, I've got degrees highlighted, so that's all good. And then if I just get out of that, I just can type it in exactly as I've written 9.6, I don't even have to put the multiplication in, sine 61, enter, and I can see I always should round to 3 significant figures, so remember that means we start from the first non-zero digit from the left, so I start at the 8 and just count 3, 1, 2, 3, but then that 0.39 will get rounded up to 0.40 because the 6 is bigger than 5. So I have 8.40. Now if I'm rounding, so x is approximately 8.40. Now normally we don't worry about writing a 0 if it's the last decimal place, but if you're rounding to 3 significant figures, you must write it in because you need to have 3 digits in your answer. And of course, if you have units, don't forget to put the units, so centimeters. All right, let's try it with another one. I'll just get a different color. So here, always go from the angle. We need to figure out which side we have. Here I can see the 7.8 is opposite the 41 degrees, so I have opposite. The hypotenuse is opposite the right angle, so I don't have that one. And this is the adjacent side. This is next to the angle. So I've got O and A opposite and adjacent. So now I'm looking at the TOA part of our SOHCAHTOA. So that means I must use tan, and it's tan of the angle. So tan 41 degrees is the opposite side over the adjacent side. Then some equation solving. Let's get rid of that fraction. Fractions always make our life harder. So multiply both sides by x. So I have x tan 41 is equal to 7.8. And I want x by itself, remember? So x equals, because it's x times tan 41, then I must divide both sides by tan 41. So 7.8 divided by tan 41 degrees. Then we're ready to put that into our calculator. Let's just move that out of the way, over to this side. And I would put that in just using my fraction function. So alpha, y equals enter, and then I can put it in just how it looks on the page. 7.8 over, and then again just type it in as it looks, tan 41, enter. And again, round into 3 significant figures. I go 1, 2, 3. This time I don't need to round because the next digit is 2, so it's 8.97. So that is approximately 8.97. And of course, don't forget units, meters. Those wavy equal signs mean approximately. All right, let's try some more. Now we're finding angles, so that's how we can use SOHCAHTOA and right angle trigonometry to find sides. Finding angles is the same method. We always start the same. So we're trying to find theta. So we still, first of all, figure out which sides we have. So here the 4 is opposite the angle. The hypotenuse is opposite the right angle. We don't know it. And so this must be the adjacent. Again, don't forget we need SOHCAHTOA. Maybe always a good idea to write that down just so you have it there as a reminder. We'll be using SOHCAHTOA for quite a few lessons in this unit. And so, because I have opposite and adjacent, I'm using TOA again, so it must be tan. So it's tan of the angle. So this is what we need to find this time. So tan theta equals, O is first in my SOHCAHTOA. So 4 over 7. Now I need to try and get theta by itself. So what we do, we have to do the opposite of tan. So the opposite or the inverse of tan is literally inverse tan. Now on your calculator you'll see that above the tan button there is a tan with a little -1, and that's the inverse of tan. It works the same as if we have squared, square root. They undo each other. So if I do inverse tan of this tan here, they undo each other, so we're left with theta. But then of course you must do it to both sides. I like to write it so you don't forget to press that extra button on your calculator. It's a little reminder. And then we just grab the calculator again. Oops, let's just get it up again. And so the only thing you have to do different, notice here above my tan button there's a tan -1 in blue, so I have to do second tan. And again, I like to get my fraction button. I really like that function in the calculator now. So 4/7 and then just enter. So again, round into 3 significant figures, 1, 2, 3. The next digit is not 5 or bigger, so I can just chop it off. So it's 29.7. Now remember, you're finding an angle here, so it's 29.7 degrees. Okay, let's just try one more before you have a go on your own. So B, let's have a look. We want this angle here. We want theta. Here, the angle, the side opposite the right angle, we know, so we have the hypotenuse. This side here, the 2.67, is next to the angle, so that's the adjacent side. Adjacent literally means next to in just everyday English. So now we've got adjacent and hypotenuse, so we're using the ka, the SOHCAHTOA. So that means we're using cos. Cos of the angle, theta, which we don't know yet, is adjacent, so 2.67 over the hypotenuse. It's very important to make sure you get these the right way around. This is why you remember the SOHCAHTOA. The order that the letters are written, whichever letter is written first goes on top. Again, we're finding theta, so we have to do the inverse of cos. And so we do cos inverse of 2.67. Good idea not to put that into your calculator and start rounding that, otherwise your answer won't be very accurate. So you always round in the very last step of your working out. Never round halfway through, otherwise you lose accuracy. So again, we just go second cos. Let's get that nice fraction happening. 2.67 over 5.92. Enter. Let's have a quick look. 1, 2, 3. This time the next digit is bigger than 5, so we have to round that up to 63.2. So it's 63.2 degrees. Okay, hopefully that was useful for you and brought back some of those memories all the way back from grade 8. Good luck trying by yourselves.